All right, we're back with systems of equations. This is actually the second version or the second part of that introduction. We talked a little bit before about what a system is and then what types of solutions you can have and what it means to be a solution. In this question, and Alex, for example, is asking, if I give you a system, can you tell me if each of these points are solutions? Remember, solutions to systems are points. It's where they meet. So I would just take those two different equations, and they're in standard form right now, and it doesn't really matter. It's fine. If this is a solution, and then I'm going to use, say, 2, 2. I'm going to skip this one just because of the larger numbers. Faster math if I use 2, 2. Let me check that one. If I'm going to check 2, 2, all I really need to do is plug it into each of these, right? So here I would have 7x is 2 minus 4 times y, which is 2. And if that equals 6, let me draw a line here to separate these things. If that equals 6, then I'm good. So this is 14 minus 8. So this is 6, and it's equal to 6 on this side. So far, so good. 2, 2 is a solution to this, but it's not a solution to the whole system unless it's also a solution to this. So let me check it. Negative 6 times 2 plus 7 times 2. Does that indeed equal 2? Well, this is negative 12. This is 14. Altogether, that's a positive 2. And lo and behold, on the other side, I also have a 2. So what I could say is that 2, 2 is a solution. Now, there are a whole lot of possible points that we can plug in and check. But if I were to actually graph these two, if I put them in slope-intercept form and I graphed them, I would end up at 2, 2, where they intersect. All right, now you can do some other practice on that. If I took a look at, say, this one, number 3, there's a graph there. And it's talking about making sure you can understand how to use this. But if you understand that this is where they are equal, and then you can see that after this point, plan A seems to be more in cost because it's a higher cost. Plan B is less in cost. So you can answer questions about this, like if he makes a 40-minute phone call, which plan is less? So at 40 minutes, which one has a lower cost? Well, it's whatever the blue one is, which is plan A. And how much less does it cost? Well, at 40 minutes, it's $4 versus $10, so it's going to be $6 cheaper. Right? For what number of long distance minutes do the two plans cost the same? Again, that's where the solution is. What number of minutes are they the same? Oh, 160. And if the time spent on a long distance call is less than this amount, which plan costs less? If the time spent is less than that, so these things, which plan costs less? Looks like plan A does. So I can just select plan A. Right? Unless I did something wrong, we should be good. I want to move on, though, to this idea of finding the system of equations, or actually finding a solution to a system of equations by graphing. Okay, so if I look at this, I need to graph both of these things. So for this example, I will need to first turn this thing into slope-intercept form so I can graph it easily. So negative 2x plus y is equal to negative 4. Now, we've done this in the other unit, so I'm going to not spend a great deal of time explaining what I'm doing, other than the fact that, hey, I'm going to get y by itself by adding 2x to both sides. So 2x minus 4. That gives me one equation. The other equation, I'm just going to write it here. It's right here. That is y equals 1/4 x plus 3. See, sometimes I like to see them together, even though I'm doing separate work. Right? So if I'm trying to check where the solution is, I just need to graph these. The first one, slope-intercept is, the y-intercept is negative 4, so there's a point. And then I need to go up 2 over 1. So up 2 over 1. There's one line. Let me add another line. This is a positive 3. And then it says to go up 1 over 4 right here. So because of that, it looks like my solution will be at 4, 4. I need to put some parentheses around that, which would be good.